Just one thing, finding maximums and minimums. That's it. And can you see why finding a maximum of this or a minimum of that could be a useful thing? Like, can you see how a business owner might want to maximize profits or minimize costs? Can you see how a land manager might want to maximize reservoir storage in Lake Dillon so that Denver, by the way, most of Denver's water comes from Lake Dillon. Did you know that? We want to make sure that's maximized so that Denver has enough water, right? If I am a traffic engineer, I might want to maximize flow rate or minimize the accident rate or something like that. So minimums and maximums, highs and lows, always going to be important to somebody. That make sense? Okay. And so I would say that your perception of what a maximum is and what a minimum is kind of depends on the world that you live in. So, if you were just to think about valor, if we said, all right, valor is our little world we live in, and I were to say something along the lines of, who is the tallest person here at Valor? What would you say? Sorry? Mr. Hovis? Yeah, he's like 6'8" or 6'9" or something, right? Mr. Dixon might be close to the same height, but it'd be one of those two guys, right? I don't think we have any high school students that are taller than that. So if I were to say, yeah, Mr. Hovis, he is the tallest at Valor, doesn't that mean he's the tallest in our little world? Right? But does that mean that he is the tallest in the world when we redefine our world to be like the entire earth? Probably not. Probably not. So who is tallest would depend on how you define your world. That makes sense? So my first 2 years of teaching after I graduated from college, I spent in Frisco, Colorado. There's no Frisco, Colorado. My number one reason for wanting to do that, I wanted to be a ski bum. And so basically I taught 5th and 6th grade elementary math at Frisco Elementary School, and I skied like 60 plus times. It was great. I ran out of money, so I had to move back down to the Front Range and get a real job. Anyways, so I'm teaching math up there, and I subbed for this history teacher, and there were some students in there. I knew most of the students, and they were talking about mountains and geography. And so one of the questions the teacher wanted me to ask them was, what is the tallest mountain in the world? And they were supposed to write it down. What is the tallest mountain in the world? And so I'm like walking around, looking at what people have written down on the paper, and they're sharing their answers. And the very first person I call on, I say, who thinks they know what the tallest mountain in the world is? This girl raises her hand. I'm like, yes, what do you think? And she says, Peak One. And it like totally throws me for a loop. I'm like, what? I'm like, is she thinking like the number one peak or something? I'm like kind of confused. I'm like, first Peak One. And I'm like, what do you mean Peak One? And she points out the window, and then it hits me. If you guys know the geography around Frisco and Breckenridge, it's called the 10-mile range. And if you've ever skied at Breckenridge, you know this. The mountains at Breckenridge are Peak 10, Peak 9, yes, Peak 8, Peak 7, I think Peak 6 now is open. And if you go all the way to the northern end of the range, right by Frisco, the northern end of the range, literally it's called Peak 1. It's the 10-mile range, 10 miles long, 10 peaks, right? And when you're in Frisco, that is a pretty darn prominent mountain. Peak 1 is really tall. It's like right there. So in this little girl's world, in her world, Peak 1 was the tallest. That makes sense? Now, if you said, on the globe, what's the tallest? Now it's Mount Everest, right? So her little world, just confined to Frisco, for her it was Peak 1, right? So tallest mountain in the world, her definition of the world was very different. And so when we look at questions like we're going to look at here, we are going to have like a world defined for us. And when I say world, I mean a domain. We're going to say, what is the maximum of this graph on this world, on this domain? What's the minimum of that function on this particular world? Does that make sense? So we might be able to find other points that are higher or lower than the points we find, but our world is going to be defined for us. So I want to present you guys with a strategy here. And there's like this nice little guidelines box up there. But I thought maybe we could look at this a little bit differently. So check this out. Take a look at number 1. It says, find the absolute extrema. Some people pronounce that extrema. I just say extrema. I don't know what the right way to say it is. So when you see this phrase right here, Find the absolute extrema. That is asking you to find the absolute minimum and the absolute maximum. So what is the absolute highest number, or highest value of this graph? And what is the absolute lowest? And you see that word absolute. That's a very key word that clearly defines that we are looking for what we call a global extrema or an absolute extrema. Okay, so here's what you could do. Now, let's get this out of the way. One thing you could do is you could graph this on your calculator and look for a min or max, graph it in the appropriate window and say, the max is this and the min is that, and my reasoning is, I looked at my calculator. So I'm sure you guys know that we're going to go deeper than that, right? That's decidedly an Algebra 2 concept. We're going to go deeper from the perspective of, I want you to know what you're actually looking for, and I want you to understand the why. That make sense? I want you to understand the concept of how do we actually arrive at these maximums and minimums, and how do we do it efficiently? So please, this is in your syllabus agreement, which I hope you actually read. Minimums and maximum finder on your calculator, not something you could ever use as a justification. That make sense? Well, you can, but you just won't get any credit for it. Make sense? Yeah? Okay. Sometimes I say that, and then on the very next quiz, somebody's like, well, I use my calculator, I use the min finder. Like, I told you can't. Well, you can, but I just won't give you any credit. Anyways, so there's that. Let's think of a strategy here. Can I present a really, really terrible strategy? Think about this. I've got f of x right here, and f of x equals 2x minus 3x to the 2/3. Do you guys see your world is right here? From x equals -1 to x equals 3. Here's what I could start doing. I could say, you know what? I'm going to figure this sucker out, and I'm going to figure it out by, please don't write this down. This is a really bad strategy. I'm going to figure it out by doing a table, and I'm going to have my x's, and I'm going to have my y's, and I'm going to start off by plugging stuff in. So I'm going to plug in a -1, and I'm going to get out a y value. And then I'm going to plug in, I don't know, -0.9, and I'll get a y value. And then I'll plug in -0.8, and that'll give me another y value, right? And I'll keep going, I'll just put a ... Eventually I'll get to, let's plug in a 0, and I'll get out a y value. Do you see what I'm doing? I'm like testing all these numbers within my interval, aren't I? And then I get to 0.1. I'll plug in a 0.2 ... And then I'll eventually get up to my 1s, 1, 1.1, 1.2 ... So on and so forth. Can you see how this would take forever? And can you see how I'm missing a ton of numbers? How many numbers exactly are between 0 and 0.1? An infinite number of numbers. So I'm like missing almost all of them, right? I'm missing an infinite number of numbers. So this strategy, really bad, right? Not only is it going to take forever, you're not going to be for sure that you actually found the thing you're supposed to find. Even if you went by 0.01s or 0.001s, you still wouldn't, right? This would include even if you used your calculator, right? It's never going to work. So instead of creating a table with a bunch of random numbers on the interval that I just pick, why don't we create a table with some very targeted numbers, right? Some candidates that actually have a possibility of being the max or the min. That makes sense? So like doing it this way, you guys haven't had a chance to vote yet, have you? Like vote in an election? So can you imagine like in the presidential election, can you imagine how futile it would be if, let's go back to the last election, maybe you did not like Clinton and maybe you did not like our current president, and you're like, I don't like him, Trump, I don't like Clinton. I'm going to write in my dad. I'm going to write in my mom, right? So you go to you can do this, right? You go to the election booth and you put your dad's name down. I bet you he gets exactly 1 vote, right? It's sad. You believe in him, and maybe if we got to know him, we'd believe in him too, but we don't even know him, so why would I write him in, right? That makes sense? This is kind of like that, right? Because what if Eden did that, and what if Jane did that too, and what if Brandon, what if we all just wrote in like our favorite person's name that we thought should be president? There would all be a bunch of single vote. It wouldn't get anything done, right? They're not realistic candidates, are they? Sorry to say. It's not going to happen. But if we target some candidates, right? You say, okay, there's Trump, there's Clinton, there's that one guy from Utah that seemed pretty good, and there's some other senator from somewhere else. Like, these are the actual candidates, right? These are the only people that have a prayer of winning the election, right? So why don't we focus on this small group of people that actually have a chance, and if we choose to cast a vote, we vote for one of them. That makes sense? And so we're going to figure out who our candidates are here. We're not going to just randomly throw people whose names we like out there. We are going to make a table, but it's going to be a very targeted table. So let's get rid of this. And if you remember from the video, that list of candidates is pretty short. There's only 2 categories. You remember what they are? Endpoints and critical numbers. That's right. So I'm going to make my table. I'm going to get started with it, and I think I'll go vertical with this table. And I'm going to say that my candidates are going to involve a -1. I'm going to leave a little bit of space because I think I'm going to have some interior candidates too. And then a 3. My candidates are going to be a -1 and a 3 and possibly some other ones. I'm not going to be random about this. So I'm looking for endpoints. I found them. There they are. I'm looking for critical numbers now. Here's where your knowledge of the video will be really important. We've found critical numbers before. We just didn't know to call them critical numbers. Critical numbers are places where f prime is what? 0 or doesn't exist. We want to consider both. And so I'd say the equaling 0 is by far the more common scenario, but doesn't exist also happens too. So if I'm going to be trying to find out where f prime is 0 or doesn't exist, I better have f prime, right? Do I have it? I don't, but I do have f. How do I go from f to f prime? It's your derivative with respect to x. So I'm going to go with f prime of x is equal to 2 minus, and this will just be a power rule. So it would be 2x to the -1/3. Make sense from a power rule perspective? So I always do this mentally, and this might be easy or difficult, I don't know. I'm going to stop and ask myself, are there any x values that will cause f prime to just not exist? What do you think? No? Anybody disagree? Anybody say yes, there are some? We're just going to go, we're voting for Santi here because he said, was that you that said no? So we all say that there are no values of x that will make f prime not exist?
I think that it's because they would have to move the 2x to the bottom.
Oh, not the 2x. Isn't this equivalent? Isn't that an equivalent expression? Doesn't a negative exponent really mean that that is a denominator?
Yes.
Yeah? Okay, so now do you see it? What's the number that makes f prime not exist? 0, yes. Because if you have a 0 in there, you get a 0 in the denominator. Yeah. If you move that x down, you can see it. So that tells me right now that 0 is one of my candidates. That's a critical number. Okay. And then we also got to check to find out where f prime is 0. So I'll rewrite this as 2 minus 2 over x to the 1/3 equals 0. I want to just take 1 second and make a mention of this. Writing down f prime equaling 0, like I did in the purple box right there, writing the equal 0 part from a perspective of conceptual understanding and being able to award credit for this, that is incredibly important. If you don't write equal 0, there is no equation to solve. If you write down equal 0, there absolutely is an equation to solve, which we're about to do. Make sense? So you definitely want to write that down. Okay, I'll get rid of the purple box. Sometimes this is the hardest part, the algebra that follows. Any suggestions on what I could do to solve for x? Say again? I think that's the right thing to do. Yeah, multiply everything. Basically clear the fraction out, right? Yeah. So I think that is the exact right strategy. That is what I would do. I'm going to multiply by x to the 1/3 over 1 times everything in there. That'll eliminate all my fractions. I think that's what we need to do. So that'll give me 2x to the 1/3 minus 2 because of cancellation equals 0. And then what? Add 2 and then? Divide by 2. Yep, add 2, then divide by 2. When you do that, don't you get x to the 1/3 is equal to 1? Therefore, x is equal to 1. Look at that, a second critical number. So I have 4 candidates, my friends. So instead of me trying -1, -0.999, -0.99999, so on and so forth, and eventually trying to work my way up to 3, I have 4 very targeted candidates. Endpoints, critical numbers. Clinton and Trump, the dude from Utah, and the senator from wherever. Make sense? We're only going to vote for one of those 4 people. Or numbers, I guess. So then, how do you guys think that I would determine what the actual min and max are? Because I got 4 candidates, but they're not all the min and the max. What do you think we would do? Try them in what?
F.
Say again?
F.
Yeah.
X.
Try them in f of x. Make them inputs for f of x. That's right. So the first thing I guess I would do is grab the calculator. Some of these are going to be really easy, but you could certainly evaluate these with a calculator. For instance, what I would do is, testing out -1 would be f of -1. F of -1 would be... Calculators, do it in your head. I don't really care. You can do all of these but one without a calculator, but feel free. Plug in the -1, what do you get out? Nope. I don't think so. You made one little tiny mistake with a sign. Just one little mistake with a sign. -5. Agreed. Okay, so that means my y value is -5. It's looking promising. The next one is the easiest of the bunch, right? What's f of 0? 0. It is. Okay, so if I stopped right there, wouldn't I say that the max is 0 and the min is -5? I still got 2 more candidates though, right? I haven't tallied all the votes for all the candidates. So I got to do f of 1. What do you guys think f of 1 is? That's -1. Yep, you guys are right about that. So -1 there. And then this is the last one is one where you really realistically have to use the calculator. So what do you think f of 3? Let's just do 3 decimals. Call it good.
-0.240.
-0.240?
Yeah.
0.240. Do you guys agree with Bailey's calculation there? I want to make sure we got that right. Okay. Awesome. Okay, so then the last thing we need to do is call out what the min and the max are. So it just turns out that the max is 0, right? That is the highest output. And the minimum is -5. So I'm going to have you guys do this. If you have your calculator with you, why don't you break your calculator out? And would you guys graph f of x on the window from -1 to 3? And I think you'll be able to see the min and the max show up. I'll do the same thing up here. I'm going to set my window to go from -1 to 3. That will be just the domain or the world, if you will, that I was looking for. And let's go with like... something like that. Getting a similar looking graph? Okay, so here's what I want to point out to you on this graph. Remember we had 4 critical numbers, right? Or excuse me, 4 candidates. So my candidates were x equals -3, 0, 1, or no, -1, sorry. X equals -1, 0, 1, and 3. See if we can spot those. So -1, of course, is the left endpoint. It's right there. 0 is right there. That's actually looks like sort of a sharp point, doesn't it? Remember how f prime didn't exist there? Make sense? Yeah? Okay. And then right about here at 1, can you see how we have, isn't that like a relatively low spot? It's relatively low, but it's certainly not the lowest. And then our last candidate was 3. You can see, of course, the y-coordinate there is just like that barely negative number.
So would that be relative max?
No, you just use the word relative. Oh, you're talking about this one right here? So the only relative max on this, and we'll get to relative stuff later, the only relative max would be that one. That right endpoint is just an endpoint. I don't think it's relatively high. This one right here, we would call this a relative min later on.
Why?
Because when you look at the area around it, isn't it the lowest point in that little locale? So local min.
So then it's not a relative max because the area around it isn't super.
Are we now? Which one are we talking about now?
The one on the right.
Yeah. So the one on the right, like I think if this graph, if we allowed it to just keep going, it would just keep. Oops. It would keep doing this, and it would not. There wouldn't be any of like if it did this, then I think we would call that a relative max. But I don't think it does do that. Okay. Great questions. Anybody else? Comments, concerns, questions? Okay, I want you guys to see the simplicity of this. Aren't we essentially just testing out x values and seeing what the y values are? But you see how we're being very systematic about which candidates we're actually using. Make sense? Okay, let's try another one here. I really don't know which one comes next, so let's find out. All right, so yay. All right, this is going to be a great question. Love it. Okay, so number 2 says, again, find the absolute extrema. So the way that we would interpret this, and if you want to be marking up your question, you are welcome to do this. This means we're looking for the absolute max and the absolute minimum. Looking for both. So I put this in here because if you watch the video, you maybe saw in the video, heard in the video, that in order to guarantee that a graph actually has a max or a min on any particular interval, there's one condition. The graph must be continuous, right? And so obviously that previous graph was continuous. We saw that when we graphed it on the calculator. This is piecewise, and these are always suspect as far as continuity, right? You could have jumps, you could have removable discontinuities, you could even have a vertical asymptote, I suppose. And so that's why this one says confirm continuity first. Okay, so let's do this. The top piece is sine. Does sine by itself have any discontinuities? No. And then the bottom piece is a cubic. What about that? Does that have any discontinuities? So what is the only potential issue here for continuity? Sorry? X equals 1, where they supposedly meet. That's exactly right. Okay, so let's think this through. How is it that I'm supposed to prove continuity or confirm continuity? What kind of a statement do I have to use? Yeah, one-sided limits. That's right. So I'm going to confirm that right here. So I'm going to say the limit as x approaches 1 from the left of sine of pi x is hopefully equal to the limit as x approaches 1 from the right of the cubic, and that is hopefully equal to h of 1. So that's that statement that we've got to write if we're going to be confirming continuity, and I think we can do this pretty easily. When I try to evaluate that first one-sided limit, we get sine of pi, and what's sine of pi? Nope, cosine of pi is -1. 0, there you go. So 0 hopefully equals, we'll look at that, 1 minus 1. Hey, 0 equals 0, and then h of 1 is contained within the cubic, and so I can say because all three of those pieces are actually equal to each other, I do have a continuous function. Therefore, finding maxes and mins makes sense. Okay, any questions here? Okay, let's start gathering candidates. I'll do this over here. What are your 2 most easily seen candidates? -1 and 4. The endpoints are always going to be considered. So I will just put those here. So x is going to be -1 and 4, and possibly some stuff in between. So I form my likely candidates from two places, the endpoints, and where do I find the other candidates? Critical numbers. Yep, critical numbers. And critical numbers are places where what is happening? Not h of x. H prime. I thought maybe you didn't say prime. Yeah, so h prime of x is either 0 or does not exist. So this whole thinking about critical numbers and h prime equaling 0 not existing, we will do this repeatedly. So I just want to make sure that you are super solid. The whole chapter is going to be about more or less this. Okay, so if we're going to be doing that, we need to find h prime. So let's see here. H prime equals, we've got to differentiate both of these pieces. And let's do the bottom one first. That looks like the easier of the two. Maybe, I don't know, it's debatable. What do you guys think the derivative of x minus 1 in parentheses cubed would be? Sorry? It is a chain rule, but what's the chain rule factor going to be? 1, right? Because the derivative of x minus 1 would just be a 1. It is a chain rule, though, for sure. So it'd be what? Got it. 3 times x minus 1 squared. It is a straight-up power rule with a chain rule factor of 1. And this, of course, is when x is bigger than 1. Okay, and then how about the derivative of sine of pi x? It's a chain rule, isn't it? Nice work. So yeah, pi times cosine of pi x if x is less than 1. Fantastic. Okay, so is there any place that you guys can think of where h prime doesn't exist, right? Because we're looking for critical numbers, and wherever h prime doesn't exist, that would be a critical number. So any suggestions, thoughts on the whole h prime not existing thing? Yes, ma'am.
I had a question.
Oh, sure.
For the cubic.
Yep.
Why is it not x times x, or 3 times x minus 1 squared?
That's what it is.
Why is it not x is more than or equal to?
Oh, the or equal to part? You point out a very good thing. That was on purpose. We don't know if h prime actually exists at 1. You're actually asking the exact right question that I'm asking back to you. I'm asking, is there a place where h prime doesn't exist? I'll circle back around to your question. The top piece is a cosine graph, right? Isn't a cosine graph, it doesn't have any sharp points, does it? And the bottom one is now a parabola. Any sharp points on a parabola? No. But you potentially could have a point of non-differentiability where these two join. So that's why I didn't put the or equal to on there, right? So let's find out. Let's see what happens. How would we determine if there's a point of non-differentiability? Do a little limit thing. Yeah, so let's go limit as x approaches 1 from the left of h prime possibly equals the limit as x approaches 1 from the right of h prime. So let's figure this out. So from the left, wouldn't that be the cosine graph? So if I try to evaluate that limit, what do I get? I think isn't it negative pi? Negative pi? Okay, and then on the right, as I evaluate that, what do I get? Interesting. And of course, those are not equal to each other. So that means when x is 1, I have a point of non-differentiability. So I've got a candidate right there at 1. At 1. So I'll put that in right here. I don't know if we'll figure out the rest of this here in a second. Okay, let's see if there are any other candidates for extrema here. That's going to be where h prime is 0. So to figure this out, what I'm going to do is I'm going to set the two pieces equal to 0 and just kind of see what happens. So I'm going to write pi cosine of pi x equals 0. If I was going to solve that equation, what would I do first? Divide by pi. So cosine of pi x equals 0. What happens next? It's interesting. A lot of students, they do kind of balk at this. They're like, I do not know what to do. Don't we want to get the x by itself?
Yeah.
There are two things with the x. There's clearly a pi and also a cosine. How, like in the process of trying to solve an equation like this, I need to get rid of the cosine, right? I need to like get it on the other side, more or less. How do you get rid of cosine? Inverse cosine. So what I'm going to do is the inverse cosine of both sides. This canceling with this, right? I'm left simply now with pi x equals, what on earth is the inverse cosine of 0? Unit circle fans, anyone?
Oh, sorry, inverse of what?
Inverse cosine of 0. Oh, you're freaking me out.
Zero.
Inverse cosine of 0, like at what angle is cosine 0? Yeah, so basically at the top and the bottom, right? So pi over 2, 3 pi over 2. There's others, right? Because we could keep just wrapping around that circle over and over again, or we could even go backwards. I do have a negative number in my domain, so maybe I should go backwards. Wouldn't negative pi over 2 also fit? So better include that. So basically, isn't it just like odd factors of pi over 2? So it'd be 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, et cetera, et cetera. Am I making sense? Okay. Just keep wrapping around that circle as many times as you need to. I think that's about as far as we need to go, because what's my final step to solve here? Dividing by pi, correct. So this will be x equals negative 1/2, 1/2, 3 over 2, 5 over 2, 7 over 2. All of those fit, don't they? All those fit within my domain, don't they? There's a lot of candidates here. So I need to expand my ballot a lot. I'm going to come back over here and say, okay, I need to expand my ballot. I know that I've got a 1 in there. I'm going to get rid of that 1. No, I won't get rid of it. I'll just turn it into a negative 1/2. And then a 1/2. And then a 1. Then a 3/2. And a 5/2. And a 7/2. Got a lot of candidates, don't I? This is more than normal. I would say most of the time you'll have just like 3 or 4. Or just practicing. This would be good practice. Okay. You guys hanging with me here? Well, we're looking for critical numbers, or critical points, as sometimes they're called. So the other thing I got to do is figure out where that other piece is equal to 0. So I'll do that over here. Let's go 3 times x minus 1 squared equals 0. Yeah.
So, but it says that h prime of like x is only like the pi times cosine of pi x.
Oh, thank you. Anybody? I was really hoping somebody was paying attention. Didn't I include way too many?
Yeah.
So where does the domain apply to just the cosine part?
That's less than 1.
Less than 1. So anything that I have up there that came from that's bigger than 1, don't I have to get rid of it? Oh, thank you. Okay, so basically, oops, I don't want to do that. Let's go with, all of these go away now, don't they? Do you know why they go away? Like, those numbers weren't even in the correct domain for cosine. So we'll just get rid of those. Okay, so, oh, thanks for sparing us that, Santi. I was wondering how long that was going to go. Okay, so now the other one. I've got to solve for x. What would you guys do first? Divide by 3. So x minus 1 squared equals 0. Now what? Square root. Get x minus 1 equals 0. Finally, we get x equals, who knows? Hey, we already had that one. Okay, fair enough. We'll just leave that there. And then, of course, let's not forget our 4. So the 4 goes back in. So we got 5 candidates. I'll stop and think about what we've done. We had this really complicated looking function. We confirmed continuity. And we've identified 5 candidates, right? Endpoints and critical numbers. These are the only possibilities for the absolute max and min. Now, how is it that we actually decide which one wins, right? Which one is the max and which one is the min? Plug it into, specifically make it the input for h of x, not h prime, right? Plug it back into h of x, because wouldn't h prime just tell us what the slope is at those points? We don't really care what the slope is right now. We care about what's the y value. So let's figure it out. Use your calculators. Let's go. We're going to wrap this up here in the next 3 minutes, right? I think our class is done at 20. So let's get busy doing some calculating. See how it all goes. As soon as you have one, just let me know. When x is negative,
Function.
we plug back into h of x.
And then also b.
And again, like, this is so huge.
Depending on which one is in the domain, that's which one's going to be.
Correct. Yeah. Yep. Whichever one fits. We're looking for the max y value and the min y value. So we're plugging back into, yeah, like you said, the appropriate piece within h of x. So yeah, so negative 1 would go into the sine of pi x. So what's your output for negative 1? 0. Good. And then I guess the negative 1/2 would still be here. So it'd be negative pi over 2. Oh, I think I know this one. So wouldn't that one just be an output of negative 1? Okay. And then pi over 2, we know that one. That'd be an output of 1. Yeah. And now we got to switch over to the other function. So you're right, 0. And then the last one, 27. Yeah. Okay. So once you have those things filled out in your table, it's a pretty easy finish. All you got to do now is say, the max is 27. And the min is negative 1. So what I try to think of is concepts, right? Like it's so easy to get buried in details. Here are the concepts. And if you can get these concepts really solid, then the only thing you have to work out is the details, and there are details, there's no doubt. But here are the concepts. We're simply looking for what is the highest y value and what's the lowest y value.
We have 2 cars parked in the Art Center that need to be moved right away so they can change some light bulbs. We're looking for the owner of a Toyota 4Runner.
Gray 4Runner and a red
145
Mazda.
RTA.
I can see them
Or
right
an
there.
Audi
Or an Audi.
QK342. Thanks so much for moving your cars right away.
Looks like a Mazda or a Nissan or something. Okay, anyways, so the big concepts are we're looking for the highest y value and we're looking for the lowest y value. And in order to be efficient with our time, we're looking for candidates that actually could be the max or the min. We're not going to just try every single number we can possibly think of. We are looking for candidates, and the candidates are always endpoints or critical numbers. Now, getting the critical numbers details, sometimes that's pretty easy, sometimes it's pretty tough. This one is pretty tough. Other times it's a little bit easier. I think you'll find the one we do next week sometime, that one's actually a little bit easier. Yes, ma'am.
For when you're finding the continuity of h prime of x,
Yes,
if it was
the continuity of h of x, actually. Oh, no, the differentiability. Yeah. Differentiability for h.
If it was differentiable, then it would not be a critical point.
Correct.
Okay.
Correct. Okay.
Awesome.
So keep at it. Keep at it. Look forward to seeing you guys tomorrow for our project. It'll be fun. Who is my police too?